students, Mr. Lawrence here, and we're going to talk today about domain, range, and functions. And yesterday we found out that the domain was the input of a function or a relation, an equation. The range is the output, and we're going to throw this word function. You've heard me use it before. And we're actually going to define it and start to recognize when something is a function. Just because it's an equation doesn't guarantee it's a function. All right, so let me see here. Uh, we're first going to need to define a function, okay? And a function is it's a relation, and all a relation is a set of ordered pairs. Okay, a relation here. It's a set of ordered pairs. Okay, for example, this here would be a relation 0, 1, the point 2, 3, right there. There's a set of ordered pairs. There's two ordered pairs in there, 2 points. Okay, it's a relation such that ST is such that, all right, um, each member of the domain, in other words, input, goes to at most one member of the range. Okay, so I'm going to explain this. I'll give you some examples, but basically what it means is if you have a member of the domain, an input number, you better only have one output number that goes with it. If you have more than one output number that goes with it, it's not a function. Okay, that's just by definition. So let's go back and look here. On 1, 2, and 3, let's identify the domain. The domain. And it looks like my domain is 1, 2, and 3, right? Okay. Now my range looks like it's 4, 5, 6. Now, is it a function? Oops, did the wrong symbol there. It's gonna let me know it's not. Alrighty, let's try that again. And I'll do a little repair job on the 6. There we go. Okay, is it a function? Is it a function? Well, let's check the domain. This member of the domain, where does he go? Only to 6. By the way, I don't know if you realize this picture is kind of weird, but this 1 arrow 6 means 1, 6. The x coordinate is 1 and the y coordinate is 6. It's the ordered pair 1, 6. 2 is going to 5, so I have the point 2, 5. This is my relation. I'm drawing my set of ordered pairs. 3 goes only to 4, nowhere else. 3, 4. So there's my relation, and yes, it is a function because 1 is only going to 6, 2 is only going to 5, 3 is only going to 4. If any one of those numbers had been going to more than one member of the output, it would not be a function. Let's check out number 2. My domain is going to be -9, -8, and 7, right? My range is only 10, 15. Now let me see if it's a function or not. I can write the relation down. Sometimes it's easy to see. Let's see, I have 7, 15. I have -8, 15. And I have -9, 10. Right? Does any one member of the domain go to more than one member of the range? No. 7 only goes to 15. -8 only goes to 15. -9 only goes to 10. This is a function. Yes, it is, ladies and gentlemen. This is a function. All right, let's check this one out. Number 3, my domain is the set 9, 10. Okay, my range is the set 20, 30, and 40, right? The relation, the set of ordered pairs, would be what? 9, 20, 9, 30, and 10, 40. Did you hear me repeat myself? Yeah, the 9 is going to both the 20 and to the 30. It's going to two members. It's mapping to two members of the output. This is not a function. It is only a relation. Only a relation, not a function. Doesn't have special function status. Okay, sometimes we have an ordered pair and we have to determine the domain, range, and whether it's a function or not. So let's see the domain. Okay, looks like the domain is 1, 2, 3. The range is 5. If you think about this pictorially, I'll bet you it's a horizontal line, right? X and Y, and 1, 5 might be there, 2, 5 there, 3, 5 right there. Yeah, we're getting a horizontal line, aren't we? Okay, now ask yourself, look at the input, the domain, 1, 2, and 3. Where does 1 go? Only to 5. 2 only goes to 5. 3 only goes to 5. This is a function. If you like the picture from the previous problem, you could always take your domain and range, kind of do this. 1's going to 5, 2's going to 5, and 3's going to 5. We don't have 1 going two different places. Okay, so this is definitely a function. All right, let's do domain and range for number 5 here. My domain is 3. My range is 6, 7, 8. 6, 7, 8. Now, is it a function? Let's get a picture of this. I've got a feeling this is going to be a vertical line. Okay, let's see here. X and Y. And I need the point 3, 6, 3, 7, and 3, 8, right? If I'm still not sure, I know whether it's a function or not, but if you weren't sure, let's see, I could do the mapping thing. 3 goes to 6, 3 goes to 7. Right there, I know it's not a function. See how the 3 is going to two different values? 3 also goes to 8. If the domain is going to any member of the domain, if it's just one member going to more than one member of the range, then it is not a function. This is only a relation. Only a relation. All right, sometimes they'll give us equations. And when they give us an equation, a good idea is to graph or to make an input-output table. So let me start with an input-output table. Let's go X and Y. And I know this equation is linear. I know that X goes forever, or I mean the line will go forever. So I might put some random points in here, -3, -1, 0, 2, and 4. Just made those up. And if I put them in the equation for x, when x is -3, y is -3, -1, -1, x is 0, y is 0, x is 2, y is 2. Okay, look like that. Now I don't see any member of the input going to more than one member of the range, but that doesn't guarantee it's a function because there might be some numbers I haven't considered. Well, let me go to get a picture of it. So let's see here. Let's go up one equation. Y equals x, and I'm going to go zoom 9, and there's my line. Okay. Look at my table over here. It shows up, see this table, 0 to 1, 1 to 1. Yeah, I don't think there's going to be any way that the same x can go to more than one y. If I really wanted to, I could trace and then move along. See, I'm only getting one value for y no matter where I go. All right, so I'm pretty convinced this is a function. All right, so this is a function. Now, this one here, let's go with an input-output table. x, y. And this one, I'll tell you what, I'm going to choose -2, -1, 0, 1, and 2. Okay. And when I do that, when I square -2, I'm going to get 4. Square, I'm going to get 1. I'm going to get 0, 1, and 4. Now, some of you might be thinking, hey, it's not a function, the 4 is repeated. But remember, -2 is only going to this 4 number. Only. It's not going anywhere else. -1 is only going to 1. 0 is only going to 0. So this is going to be a function. Now, getting a picture of it would be a good idea. You don't know how to graph this by hand yet, but let's go ahead and do it on the graphing calculator. And y equals x squared, and I'm going to graph it. And I get that parabola shape. And if I look at this t-table, I wonder if I can make that table pop up. Hold on one second. There we go. I found my table. I said 1's going to 1, 2's going to 4, 3's going to 9. Those are the squared numbers, right? But I think I can move up on that table, see? And I'm getting the squared numbers again, but each member of the input is going to no more than one member of the output. I'm having the same output show up, but I'm not having two inputs going to one output. In other words, there aren't two different x's. I'm sorry, there's not one x going to two different y's. So this is going to be a function. All right, let me go back to y equals. And this is a different one, number 8. In fact, I'm actually going to move it to give myself some more room here. Move it down here. You're used to equations saying y equals, and this says x equals. So you know what I'm going to do? I'm going to solve for y. Well, how do I undo a square? Well, I take the square root. Now you got to be careful here because it is going to be y equals, but it's going to be plus or minus the square root of whatever x is. Remember that um, the square root of 100 is equal to positive 10 or negative 10 because 10 times 10 is 100 and negative 10 times negative 10 is 100. So when I go to do this input-output table, it's going to be a little bit different. I'm not going to make the whole table at once. I'm going to make it as I go. And I'll tell you what, I'm going to take a real easy number. And I'm going to put 0 in there. All right, square root of 0, 0, no problem. Now I'm going to put 1. What's the square root of 1? Well, it could be 1, but it could also be -1, couldn't it? Right? Okay, if I put 4 in, I get 2, or I also get -2. So this input-output table looks really strange. Maybe instead of doing it that way, I want to do it like this. Let's see, let's go x and y. And I won't be able to show the whole, all the possibilities, but I was putting 0 in. I put 1 in. I'm going to put 4 in. And let me see, 0 mapped to 0, didn't it? Just like that, right? But 1 could have been 1, or it could have been -1. So it's got to go to two different places. That should be your clue right there, that it's not a function, because 1 is going to two different numbers. 2 is going to two different numbers. It could go to -2. It could also go to +2. So this is not a function. By the way, if you want to do this on the graphing calculator, you have to do it as two functions. Y equals the square root of x, and also y equals the negative of the square root of x. And since we did that, I'll go ahead and show you. Where'd we go here? All right, so we're gonna, let's see here. We need the square root of x. Oops, got an extra little symbol there. You know what, I can make that the -1. Um, okay. You have to do as two separate functions, just the way the calculator's programmed, that's all. And then the square root of positive, or the positive square root of x. And so if I graph now you you might be able to see more readily uh, how right here, let me make this really big. Okay, this is the point 4. You see 4 has a value up here, but it also has a value down there. You see that? Okay, that's not a function because uh, 4 is going to 2 different numbers, as are all the positive integers for x. Okay, 0 is the only one that's not. If you want to go into table, notice all these errors. That's because we can't take square roots of negative numbers. So let me get to the positive numbers. And look at this. Look at this table here. It tells you 0 goes to 0, but then 1 has 2 different answers, a y sub 1 and a y sub 2, right? Yeah. Those aren't perfect squares. 4 goes to 2 or negative 2. If I go up to 9, I get 3 or negative 3, etc. Okay, so that's domain, range, and functions. We'll get a little practice with this. Mr. Lawrence signing off. Have a good night, everybody.